Hey guys, and welcome back to the channel. This is Chris from Moralis, and this is going to be a collection of videos all stitched together as a tutorial series enabling you to get yourself started with Ethereum programming for beginners. Now, we've got a lot of HTML and CSS and JavaScript tutorials a little bit later on to build what you can see in front of you here, which is essentially a login page built with Bootstrap and Moralis that helps you authenticate users with MetaMask, sign them in, and once they're signed in, they can have a couple of options to look for different transactions on their account, the different balances on their account, and the different NFTs that they have in their account, and display them on the application. I'm going to talk you through how to do all of that. Now, if you're less familiar with this kind of stuff, then we'll start from the beginning. I'm going to show you all the different tools that you're going to need to get yourself set up. So that'll include things like getting MetaMask installed, getting Visual Studio Code installed, even getting things like Node.js and Truffle installed, so Ganache, I should say, so you can build local blockchains on your computer. I'm going to show you how to fund your wallets because we're going to be using a testnet to build all of this today called Rinkeby. So I'm going to show you how to create all of that and fund them with some pretend ETH, so you can create transactions to and from all the different accounts that you'll have on MetaMask, build up a bit of a history of transactions like this in front of you here. And once you've got all of that and you've got some NFTs and things in your account, we're then going to be able to use Moralis functions to pull all of that data into the application and have it styled and looking like this. At the end of this series, if you follow it through like I have, then this will be what you will create. Let's jump straight into it. Okay, so to help you with your viewing of this video, if there's a specific section you want to skip to, then use the timestamps below. The first part of this video, we're going to be looking at getting the developer environment set up. We're then going to be looking at funding wallets and getting MetaMask set up, and we're going to do all of that before we jump into the development. If you're only interested in the coding part of this series, then just skip to that. The login component, I think, is what you'll want to jump for. But we'll jump in straight away with getting our environment set up first. This video is designed for those just getting started with Ethereum programming and dApp development. The goal of the video is to provide a quick start guide on the tools that you'll need to get building with Moralis. So what we're going to look at is we're going to look at installing 4 particular softwares or pieces of software. We're going to look at installing MetaMask, Visual Studio Code, Node.js, and Ganache. So let's just jump in and start off with MetaMask. Now, you probably already have this, but if not, just go and get it. It's a cryptocurrency wallet used to interact with the Ethereum network, and it does this all through your browser rather than a standalone piece of software. You manage your keys, you send, receive ETH-based tokens and cryptocurrencies, and broadcast transactions to the network, all of that great stuff. Now, the Moralis applications that we're going to be building are all going to be leveraging and using MetaMask to help your users sign into your application, to sign transactions in the browser, and all of that. Plenty of MetaMask tutorials on the tube. So go and check out some of those if you've never used it before. Perhaps in another video, I'll show you how to use MetaMask and interact with a testnet and local networks as well. Now, there are other ETH-based wallets available like Exodus, Mist, and things like that, but I'm just going to recommend MetaMask because it's the standard. So search for MetaMask, click on download, download it, install it to your browser, and that is pretty much it. It should be nice and straightforward for you. Okay, the next thing we're going to need to do is set up the IDE, the code editor. Now, you're going to need a solid code editor, ideally one that has access to a command line or a terminal, and one that can give you access to running a live server so you can test your applications while you develop them. Lots of good options on this front again, but the one I'd recommend is Visual Studio Code. You can download it for free, get it installed, open it up, and once you've got it, it will give you something that looks, perhaps a little bit like this, which just has a simple template in there at the moment. But when you load it up, you will have your entry screen, and you can start creating new files and get coding. Now, there's a few things I want to talk you through. First thing is that you'll want to get a few extensions installed for Visual Studio so you can code in Solidity and it will understand and help you out with a few, maybe debugging or snippets. So you can go to the extensions section on the left or view extensions and install. I've got 3 things installed at the moment. I have Live Server, which is the key one. I have ES7 React Redux, and it's a snippets extension. So it will just pre-fill things like React function components and things like that. It will just give you the code as templates and little snippets. And the other one is a Solidity plugin, which will just help it understand and highlight the different parameters, variables, functions, etc. when you're programming in Solidity. So that's for a little bit later down the line. But they're the 3 extensions that I'd probably recommend to get installed. And also you can view terminal, get familiar with that as well, because you can jump straight in. Once you've got Node.js installed and other things, you can interact with your application directly from the command line here. And you can use PowerShell or Git Bash, command prompts, things like that, all from directly within Visual Studio Code. So highly recommend going and getting that one. Okay, the next thing we're going to need to do is install Node.js. You probably already have it installed, but perhaps you're a PHP developer or a Python developer and you've come from a different environment and you've not needed to use Node.js. If you haven't, then just go and get it, install it, because when we're building dApps with Moralis, we may need to go out and execute JavaScript outside of the browser, or more importantly, install some packages, NPM packages, for our application, and to do that, we'll be using Node. If you're not sure if you have it already, but you've just installed the Visual Studio Code, you can just simply type Node in the command line and it'll tell you. And if you've got a version number that's coming up, then you know you have it installed. But if you don't, it will probably just throw an error and say that it's not defined or whatever it might say. So go and install that. It's easy to do, and once it's installed, you'll be able to interact with it through the command line. And the final thing that we're going to do is install Ganache. Now, I have all of these things installed anyway, so I'm not going to talk you through the install process. You'll be familiar with how to do that yourself. But Ganache is useful for creating local blockchain environment on your computer, because unless you have an unlimited pool of funds, you're going to want a sandbox blockchain to build your dApps on before you put them live on a mainnet or even a testnet. So you'll want a blockchain to practice on, and the one that I recommend is Ganache. Again, there are others, but that's the one. Once you have Ganache set up, you'll probably see something like this, and you can just simply click Quick Start or New Workspace, and once you're in, it will give you a whole bunch of addresses that you can use in your applications with some fake money to play around with. So again, really, really useful. Now, with those 4 tools, so MetaMask, Visual Studio Code, Node.js, and Ganache, we're pretty much ready to go and get started. Now, this video will show you how to create a local blockchain so you can begin testing your applications and interacting with smart contracts. I'll explain why you need a local blockchain and help you connect it to your MetaMask as well. We'll create a new network, import a couple of accounts, and send some test transactions, all of which will help you when you're building your applications with Moralis. I hope the content's useful, guys. If it is, leave a like, subscribe to the channel, join the Discord as well. We'd love to hear in the community what it is that you're building with Moralis. Okay, now as an Ethereum programmer, I'm talking about you, and a blockchain developer, you're going to be building applications that will interact with smart contracts. And when you develop these applications, you need to be able to test your code quickly and make sure that when you're making Ethereum-based transactions, they're quick and you don't have to wait for an on-chain transaction to confirm before you continue building your dApp. So in order to do that, you need to start with a local blockchain. And there's 3 steps to the whole dApp process, if you like. Step 1 is testing your dApp on a local blockchain. So on this image, it would actually be over here. And that local blockchain is private to you. It's completely immediate whenever you make a transaction. And that's what we're going to work with today. Once that's complete and you've built your application and it's ready to be tested publicly, you'd put it on a testnet, testing environment, fake transactions. And still, it's not real money, but it gives you the feel that it's actually gone live to the public. And then once that's ready and all the bugs are ironed out, you can then put it onto the mainnet. Now we're at step 1, and that's what we're going to work with today. Now to get yourself started, you need to install Ganache. You probably already have it from the previous video in this series, but if not, just go and Google install Ganache. It'll bring you to this website, download the software, install it, and then you'll be given something that would probably look a bit like this. It might not even have one, so it'll probably look like this. So what we'll do is we'll just create a new workspace, Ethereum, and we'll call it something. call it whatever you like, and then we'll click Save Workspace. Now, we're not going to import any truffle projects, so don't click Add Project. We'll do that maybe a later date when we get a bit further down the line in this series. So that's all we need to do. We'll save the workspace, and there we go. And now we've just been given 10 different addresses as part of our local blockchain. Now, this blockchain is automatically mining, so whenever we're interacting with these addresses, making transactions with them, they will be mined as part of a regular block on this local blockchain automatically, so it will be immediate. Each of these 10 accounts has an address. They each have 100 ETH. It's not real ETH. It's just faked local blockchain test ETH. And each time we create a transaction on these using these addresses, they will be recorded in our Ganache instance as well. Okay, we've got some information up here which we're going to be using in a moment to connect to MetaMask. And we're also going to need our private key for whichever account we want to use. Okay, so let's jump over now to MetaMask and get them connected. If you don't already have MetaMask installed, go back to the previous video in the series and get that installed in your browser. Log in, and once you have logged in, you'll be given something that might look a little bit like this. Yours might be empty, might not have anything in it, but you'll be given the different networks that you can connect to up here at the top. Mainnet, the different testnet networks, and you can connect to a custom RPC or new network, which is what we need to do now. So to connect to Ganache, let's click Custom RPC, and we need to fill in 3 pieces of information. The network name, we'll just call first Ganache. You call it whatever you like. The next one is the RPC URL. We can go here to our Ganache, copy that, RPC server URL here, paste that in there. Now for chain ID, just use 1337. Okay, I started off by actually pasting in 5777, which was the network ID here, but it gave me an error and said use 1337, so I did, and it works. So it'll be the same for you. You can leave these last 2 options blank, click save, and once you've done that, it's been added there at the bottom. So we've added our first network. You can X out of that now, and you'll see that we're actually using the first Ganache network, and there's nothing in it. It's empty. Okay, so what we need to do is import an account. So actually it says 100 ETH here, so we can take it from one of these. And in order to do that, we need to import the account. And to do that, click on the icon at the top right, import account, and you'll need to paste the private key here. Now, I'm okay sharing the private key with you because I would have probably deleted this account by the time you view the video, but it's test ETH anyway, and it doesn't really make any difference. I'll paste that in there. And once you press import, you can see it's done. Now it's called account 4 at the moment, so let's just change that by clicking on the 3 dots, go to account details, click the pencil, and we'll just call that something like Ganache number 1. Call it whatever you like. Click the tick, and then that will be done. Okay, so in our accounts list, we've got a few different ones, and then Ganache 1 is at the bottom imported. So that's the first one. So we may as well import a second one as well, just so we can send some transactions between the 2 of them. So we'll go and import this address here. We need the private key, copy that. And then we go back to MetaMask, click the icon at the top right, import account, paste in the private key, import, and there you go. And again, we'll just rename that quick to Ganache 2. And there we have it. So we now have 2 different accounts that are funded with 100 ETH each. And if we look here, it says it's not connected, but that's because we're not interacting with this particular truffle website at the moment, and we haven't got an app to interact with yet. We're just going to send some transactions to and from those addresses, and then show how that what difference that makes on the Ganache blockchain here. So I'm in Ganache 1 at the moment. I will copy this address because I'm going to go over to Ganache 2 and I'm going to send the address that I've just copied from Ganache 1. I've just pasted that in there. It automatically provides this new screen, and let's just send 12.78 ETH, whatever number you like, as long as it's not more than 100. it will let you do it. So we'll click next. It brings up the usual confirm screen. That looks good. Press confirm. And it says here at the bottom that in the queue, it's pending to send 12.78 ETH to this address here. Now, it might take a second or two to show up, but eventually once that transaction has confirmed, well, it just confirmed right there, you can see now after the fee that that 12.78 ETH has been taken off, and you'll see it appear in this one. There we go, 12.78 ETH. And in our Ganache, we can also see that that's updated here as well. And we don't necessarily have to have the accounts connected in here to send money. So for example, if I now want to send some ETH to this address, which is not connected to my MetaMask, we'll just send that to that address. Maybe we'll just send 1.2 ETH. And again, we'll just leave all these details the same. We'll confirm the transaction. It goes into our pending queue. And again, it might take a second or two for that to go through. But once it does, in fact, it already has on Ganache gone through. You can see here that now the balance is a little bit lower, 111.58, but the other address is now just updated on the right. The other address has the extra 1.2 ETH. Okay, and there are transactions, as you can see, that are in here. The transaction I created was to send money from this address to this address. That was the first transaction here, and then from this address to this address. We've already set up a local blockchain using Ganache. We did that in the previous video. This time I want to help you fund your wallets with public testnet ETH rather than local blockchain ETH. So what is testnet ETH? Well, in our MetaMask, we saw before when we were adding some accounts, there are different networks available for us to use. So for example, you have Ropsten or Rupsten, Kovan, Rinkibi, different test networks that we can connect to. For today, we're going to specifically take a look at the Ropsten or Rupsten and Rinkibi test networks, and we're going to go and see how we can get some money put into those accounts for us to use when we interact with smart contracts or an application somewhere out there. Now, you know what the Ethereum network is already, or at least I hope you do. Now, Rupsten Ethereum is a test net, also known as Ethereum testnet. Rinkibi is pretty much the same. And it allows Ethereum programmers and blockchain developers like you to test your work in a live setting, but without the need for real Ether. Now, you can buy real Ether from an exchange, or you can buy it peer-to-peer, or you can mine it or even stake it, depending on when you're watching this video. But with testnet, you don't buy it. You can mine it, but you probably don't need to. But you can fund your testnet wallet for free using particular websites and faucets, which is what I want to show you how to do today. So the first thing that we want to do now is go and take a look at funding our Rupsten account. So we're going to need to go and use one of the faucets. Now you can just simply Google that Ropsten or Rupsten faucet, and it will bring up a few different options. This is the first one, faucet.rupsten.be. And what it wants you to do is enter your testnet account address and then click on send me test ether. So let's just do that. So I've got here Ganache 1 was one of the accounts I set up last time. So let's use that. We'll just change our network to Rupsten test network, and then we'll copy the address to the clipboard, paste it in here, and send me test ether. Now that request gets added to the queue. And it says here that the faucet drips 0.3 ether every 10 seconds. And you can register on your account in our queue, and let's see whether or not that actually does work for us. We'll just click here on our MetaMask, and so we currently have nothing. We may need to wait for some time, so maybe I'll just go and put on a coffee. Okay, false alarm. I was just about to go and put a coffee on to come back, but as I got up to do that, it came back, and now we actually have 0.3 ETH inside our Rupsten test network. Testnet network. The double net always catches me out. Okay, so that's the first one that we can use, so you can do that. It's pretty slow. I mean, 0.3 is not a lot, and I don't think it continually adds it either. It's just one time each. So let's just go and see if there's another one we can use. Here we go. So this one is faucet.dimensions.network, and it's an RE faucet. It received 5 per request, so let's see whether that works for us. I'll click on the captcha. Looks like an exhaust. Oh well, I passed the test apparently. Okay, and congratulations, your address has been added to the queue. And so please consider sending us an airdrop of your new tokens, it says. So if you want to do that, then you can. You can see here there's a list of all the different addresses that have received their 5 ETH, and actually quite a lot of them have happened in the last 10-20 minutes or so. So let's see if that comes through onto ours. Again, it might take a few seconds for that to come through. So I'll just pause the video and then I'll wait and see how long that takes. Okay, so the 5 Ether went into the account, and while I was offline, I just did a transaction between 2 of my accounts using MetaMask where I transferred 1.75 ETH from one account to the second one, and that transfer went through. And so what I'll do is I'll just show you how I did that. You have to get the address from wherever you want to send it to. So I want to send it to this account. I'll copy that address to the clipboard. I'll go back to the account that I want to send from. Send. Paste the address in here. Choose the amount that you want to send. Let's say I want to send 0.85 ETH and click next. Confirm the transaction. And then you'll need to wait some time because that transaction will be pending. And because this is on a test network, not a local blockchain, the block would have to be mined. So that will take a second or so to update. So I'll pause the video and come back. There we go. I didn't have to pause for very long. It only took about 30 seconds or so. And the transaction's confirmed. So this account is now 0.9 ETH and the other account is 4.4. So that is how you would fund your account with Ripston Test ETH. So what we'll do now is take a look at Rinkeby. And to do that, we'll just choose the Rinkeby test network. 0 ETH in there. And we're going to use Rinkeby Authenticated Faucet. And that's located at faucet.rinkeby.io. And what you'll need to do is go on a social media, for example, Twitter or Facebook. You'll need to take your address from one of your accounts. So for example, the Rinkeby test network for this particular account, let's copy that address. You'll need to create a post on your social media, and I've created a Twitter account specifically for this purpose, and you'll just need to say or reference that address in there. Funding my Rinkeby wallet with test ETH, and then publish the address here, and I'll just put that tweet out. Once it's published, I'll need to get the URL from that tweet. So I'll just click on that, click the link, copy that, and paste it. Once you've done that, you can choose between 3 options. You can either request 3 ETH every 8 hours, 7.5 every day, or 18.75 every 3 days. Now that's not an automatic funding. That's just how often you'll be able to do it. You'll have to leave it 8 hours or 1 day or 3 days. So we'll go for the 18.75, and then I'll just pause this while I pass this test. And there you go. So now we have a funding request accepted for the Twitter account that I used, and we'll wait however long that might take to come back and fund our account. Wow. Okay, well that was super quick. It took a matter of seconds. I think I was one of the only requests in the queue, and it funded the account almost immediately. So let's just do the same thing again now where we switch some ETH or swap some ETH between the accounts. We'll go to our receiver account. We'll copy that address. We'll go back to the sender account, and let's go and send 10 ETH, a healthy amount. Send that, confirm the transaction, and then we will wait for that transaction to go through. And the transaction's confirmed. So that account now has got down to 8.75 ETH, and the other account received the 10 ETH. And there you have it, guys. That is how to use the different faucets in order to fund your account. The Rinkeby Authenticated Faucet and a couple of different Ripston faucets that are freely available. You can enter some information, including your addresses, into that to get your account funded with free test Ether. Guys, if that was useful, leave a like on the video, subscribe to the channel. There's lots of new content coming out every day from Moralis. Get yourself involved in the Discord channel as well, and then join me again in the next video. So let's start building. This is the application we're going to build together. It's a 2-page website. It has a login component, which will allow us to sign in or register a user with MetaMask, and also assign a username and an email address and save it to their account, which will be in the database. So as an example, if I just logged in, and I can create anything here, it doesn't matter. And so chris@gmail.com with the username of Chris. I'll just sign in. Asks us to sign with MetaMask. Once we've done that, it will log us into our dashboard. So this is page 2 of the application. Again, this is another component which we will talk through. It's called Super Awesome Dashboard. It has a search bar at the top. It has a sign out button, and there are some functions down the left-hand side that will display some data. For example, when we click on transactions, it will search the current logged in user for their transactions, and it will return this information where the transaction will link to Etherscan, the Rinkeby Etherscan, which is the testnet that we've used for this application. So that's great. And it does the same for block. And it will also return the age of the transaction, the type, whether there was a fee and how much, and what the value of the transaction was. So there's a bit of data there, and there's multiple transactions that it will return that data for. So that's good. Lots of stuff that happens in here, which we'll go through together. We also will be able to create a function that returns the balances of the logged in user for Ether, Rupston, and Rinkeby, and the balances for those as well. And it will search the current user for their NFTs, which will, in this case, just provide a single NFT because that's all this account has. But if a different account has more NFTs, then it will return all of those in this list as well. Okay, so that's what we're going to build together. This search bar is not connected, but that will be some homework for you guys to connect and add some extra functionality to this app. But be really keen to see what extra functionality you guys build into this using some of the Moralis functions that are available for you. I'm just going to sign out of this one to just bring us back to this screen, and this will be our reference point. But what we now need to do is start a brand new session in Visual Studio Code and start bringing in all of those features and pulling it together. Okay, so I've got a session here set up. My extensions include the live server extension. We'll be needing to run that once we've got our code together. And to get started with this app, we need to go to Bootstrap and get our boilerplate code. So load up a new tab, type in Bootstrap, and it's getbootstrap.com that we need. Jump over to that. The components that we want to use, which will be under examples at the top. And the examples we need are dashboard, which is over here, and sign in, which is this one here. So we'll download both of these here, download the examples and download the source code, extract the zip files, and we're going to need to collect some of that in just a second. Okay, so I have 2 Explorer windows open here. The first one is my session window, which has no files in it. It's completely empty. And the other folder that I have were the downloaded Bootstrap folders. This particular one is the examples. And in here, I'm going to go and get dashboard and sign in. I'm going to copy those into my session folder and then maybe just extract what I need from them. So this is the dashboard. So let's just go and paste those files into the root directory. That index file, I'm just going to rename that to dashboard. I actually don't need RTL, but I'll leave it there for now. And in the sign in folder, we'll copy that and we'll paste that in here as well. We'll leave that as index because that we can start building that as our home page if you like. And then we'll just tidy up these files by removing those 2 folders. Go back to Visual Studio Code. You can see that they've updated. And let's just go into the index file here. So this is going to be, I can probably run this. It's going to look horrible, I think, but let's just run this and see what we have for the moment. And it's listening on there. Okay, so we've got the basic HTML here, but certain things are not connected. So we need to go and connect some CSS and other bits and pieces to make Bootstrap work properly for us. Okay, so let's just close these messages. And we'll start looking at what it is that we need to connect first of all then. So we've got our basic meta up at the top in our head. We've got a title here, which we can just rename the login component. What else do we need to think about? Well, at the moment, we have a couple of links here for our CSS. That's good. We're going to need to build a style CSS, and we're going to also need to go and connect our sign-in CSS. So let's go and create a link to the sign-in first of all. Now, as far as file organization, I wouldn't recommend having everything all in the root directory like this. I would organize it out a lot better, but for the purpose of the tutorial, I'm just going to leave that as it is. Now I can see here that this won't work because I've got a link to a distribution or dist folder from our core Bootstrap, which is the other file we downloaded a moment ago. So I'm going to need to extract that and put some files into our session folder. So let's go to the other download that we had from the Bootstrap website, which will look something like this for you. There we go. And what we're going to need to do is go and find that dist folder, which is this one here. And I may as well just copy both of these two folders into the project and put them in there. Okay, so that's the CSS, and in there's a lot of Bootstrap CSS files. We won't need all of them, but for the purpose of this example, that's fine. And the same for the JavaScript. There's a whole bunch of JavaScript files as well in there, which we can now use. So now we can reconnect this and just change it to that. Okay, so let's save that. Let's go and have a look and see what difference that makes on. Well, straight away, it already looks like the application. The only thing that's different here is this image. We don't have that image. So if we just went to Moralis.io, and let's go to the documentation because we might need that a little bit later anyway. And this is the image which we'll just take and put into our session folder, and we'll just drop that there. Called something a little bit unusual, so we'll just rename that to Moralis, and that'll be a moralis.png file. So let's go back to our code, and where is it referencing that? Referencing that image here. And we're going to change that to moralis.png, save that, go back to our component, and we're pretty much there. Let's just see if we've got everything the same as our reference. Okay, the only difference I can see here is this is not there. So let's go and remove that from our code. Okay, so we've got some style here. We'll just probably move that into a style CSS file just to tidy things up. We've got, actually, I think we've now got two references to that CSS. So we'll just remove that second reference there because it's already up here. What else have we got here? So we've wrapped everything in a form tag, which is not what we want. So I'm going to remove that because a form will have slightly different behavior that we want for this application. We were looking for the checkbox. Where's the checkbox? Here we are. So we can just remove that entire div. And that takes out quite a lot of the code that we didn't need. We'll just remove that. And there we go. Okay. So we've got the basics of our form. It doesn't do anything at the moment, but it's there and it looks similar to how we wanted it to look. So that's great. Now what we can do is just start connecting some of the other bits of this HTML so we can start putting our JavaScript together here. And so we're going to create a new file, and let's just call that main.js. And in here there isn't anything, so we'll just do our standard hello world. And we'll just connect that into our HTML. Let's put that down just next to the body tag here. We'll just create a new script tag with some source. And we want to connect to our main.js. And if we run that in the browser, we should hopefully see hello world. Good. So we've connected the JavaScript. Okay, now let's connect our server. So we'll go to moralis.io. Let's log in. And we're going to go to a Okay, it's already I'm already logged in. So it's going to go to our dashboard. If you don't have an account already, go and create an account, verify your account, and then log to the service page here. You may or may not have servers set up already. You probably will be able to have a maximum of 3. If you don't have any, then just create a new server, call it something, do a mainnet server, call it something, choose your region, select the networks, click all 3, and then add the instance. It takes a couple of minutes to spin up, but once you have it, this will be mine here. Go to view details, and in a moment, we're going to need to take the server URL, put it here for the moment, and we're going to need our application ID. I'll just put that in there just for the moment so it's off of our clipboard. And we need to connect our server. So we go back to the Moralis website. We'll go to docs.moralis.io, or from the homepage, you just click on documentation and it will take you to the same place. And I'll use my favorite page, which is the build a simple dApp in 3 minutes. Most of my tutorials use this source code. And for the minute, I'll copy all of this, and then we'll just take the bits that we need. So, well, first of all, let's just put it down here. And let's see what it is that we need. Well, we've already pretty much got these 2 HTML head tags already. There's a lot of stuff we're not going to need here. But what we will need is the Moralis SDK code here. So let's just move that somewhere up there. And don't like having any style in my HTML. That's just my preference, really. And I also don't like having any JavaScript in my HTML. So I'm going to move this connection to the Moralis server. We'll take all of that into here. And we've already got our server URL. We took that a moment ago. Let's just paste that in here. And we also have the application ID here. Okay, just format that document just so it looks a little bit better. And there we go. We don't really need this console log, but you know, we'll keep it there for the moment. So that is the connection. We'll save that. Before we save our HTML, let's see if there's anything else that we need here. Empty script tag. There's just 2 buttons and a H1 tag. There isn't really anything else that we need there, so we can just remove all of that. Okay, save that. Good. Just for simplicity, I'm going to create in here a style.css, just in case we need to add any extra styles to our file. Let's create a link to that here, so we can just copy this one and call that style CSS. And I'm just going to move all of that out of the HTML just to tidy things up a little bit. Save that and save that. Go back and check on our application, see if it's broken anything. Doesn't appear to have broken anything. That's good. Okay, so what's next? Well, let's just take a final look through our HTML. And so we have the core parts seem to be okay. And we probably just want to take a look at this because we're not going to be interested in a password here and email address. So let's go back to our reference. What did we have? So this one is email password. And this one is username, email address. Okay, so let's just swap those around to username and email address. So let's move this underneath the password and we'll just change this to username. And well, floating password, I mean, that doesn't really mean anything. So let's just say that it's, or name it whatever it is. It's the user's username. And that's the username. The label we can change to be that. Actually a text type. So now we have a form floating div, which has an input, which is a text, has a class of form control, an ID of user username, and a placeholder of username. The label is for the user's username, and the label will say username. Simple. Okay, good. And the final one we can probably just change will be this one. Now this is the user's email. We'll just change that from what it was before. And I think everything else looks pretty good. Okay, good. I think the HTML is pretty much done. Most of the time now will just be spent inside our JavaScript and getting all of that set up as well. All right, so what do we need to do then? Well, as soon as somebody clicks on the login button, we want to log them in. So we're going to need a function. And we may as well just write that out from scratch. So let's just do the basics. It's going to be an asynchronous function, which will do something. So what we need to do is go over to our documentation and find that something. So here we go. Onto the Moralis, docs.moralis.io. We'll go to users, and it's a crypto wallet login. So we'll use this one. And this would work just fine. So we'll go and grab this, and let's just put that into our code. And okay, what I think I will do with this one is just put a wait before the function. All right, so when login runs, we are going to await the moralis.web3.authenticate. That will do all of the heavy lifting of authenticating our user. Then what we want to do is run an anonymous function. Actually takes the information from our user, and then it will console log the user's ETH address. Now, we're not really too bothered about it doing that, so we'll just simply put a message that says logged in, just for now. Logged in. And then we'll do some other code as well, of course, but that'll do for now. So what we need to do is connect that login button. So when somebody clicks on our applications button down here, it will be able to run that login function. So what do we call that function? Do we have an ID attached to that button? That's the first thing we need to check. So we go back to our HTML and we'll look at our login button. Do we have any ID attached to that button? Because I don't think we do. And in that case, we need to go and write one. And we'll just call it BTN login. That's the ID for that button. So save that. And go back to our JavaScript, because we're going to need to create a listener that will actually listen to that button. And it will just be a simple bit of JavaScript. We'll just use a query selector. You can use getElementById if you prefer. And the element is hashtag because it was an ID rather than a class, which would be a full stop. So this document.querySelector.btn.login will go and find that button from our HTML in the browser. And then when the onClick is pressed, or is activated, if you like, it will run login. So that's what we want it to do. So we'll just leave that as it is, save that, come back here, and we'll test it. So we'll clear the console, and let's see if anything happens when we press that. Well, it's running all of the functionality that we need automatically. It wants us to connect to a MetaMask account. I've got a number of different ones here, so I'll just go ahead and connect with that one. And let's see what it says. Okay, it wants us to sign the request. And there we go. It says we're logged in. So it now has completed this functionality, and it has said user logged in. And I wonder whether we might even be able to get some more information from the user. So there is a function we can dial into here, which just gives us the current user. So let's just find out whether that works. Sign in again. And there you go. Okay, great. So we have an active user. And inside here, under the attributes, for example, you can see the user's Ethereum address. And that is my actual user. So great. I'm authenticated, although it's not done anything useful just yet. But behind the scenes, I have that user authenticated. And so I can go over to the Moralis dashboard, and I can go into the database. And I should be able to see that there is now a user in my database. There it is. Great. Now, there's nothing identifiable about this particular user apart from their address at the moment, their ETH address. That's their main unique identifier. So what we want to do is we want to start assigning a username and an email address to that particular user, because at the moment it's currently undefined. So we now need to go and add some extra code to our login function. So it will connect to whatever we put in these two fields. Well, if we hop over back to the documentation, there is a useful section under the getting started quick start, I believe it was. It's worth reading through all of this. If you're not familiar with it, just pause the video now and just familiarize yourself with this particular page, because a little bit further down on this page, from memory, there is a section that will, here we go, there we go, that will enable you to set attributes to a particular user. And the way that you do that is you hook into the user and activate the set method, and you can set a field name to a particular value. And then you can do that with whatever fields you need. And then once you're complete with setting, you then need to save the user. And once that's done, that's pretty much all of the really heavy stuff complete in your code. So we can actually copy this, put it into our file here. We don't need this now really, so we can just replace that. Maybe we'll just keep logged in just so we can see what it is, and we'll tidy this up. And at the moment it's setting a phone number to this and a birth date to that. Well, we don't want to do that. We want to set the username and an email address. We'll just call this name, and make sure you spell it correctly, and we'll call this one email. And then we need to think about, okay, well, what is it that we're going to get, and where are we going to get it from? So where are we getting the email from? And where are we getting the username from? Well, at the moment, we're going to be getting it from our application, and we're going to be getting it from whatever they type in here, aren't we? So how do we get access to this information? Well, that will be based on whatever ID we've used in those fields. So there's one, user username, and the other one will be user email. So we're going to need to go and start using that in our code, and we can just put that directly into those fields. So let's see how we might do that, and go back to our main.js. So in here, we're going to go with a document, and we'll use getElement by ID this time. I've used query selector before. And I pressed Control B instead of V. And the user, what will that return? Nothing, because we need its value. And let's put that in there. And we can just copy this one, because the other one, pretty similar. It was the user email. Okay. And then we've got the save, and that will work with a single page application. The only tricky thing is that if this is a 2-page application, this particular field may not be on that page. So it could add some errors into our console, because it will say, well, I don't have this element on this page. But we'll leave that one for now, and we'll come back to that when we get that issue. So we'll save that. We've got an error, and we need to make sure done something not quite right. Let's just figure that out. We have not closed off our function, perhaps. Let's just see. So the error is on line 12, and it's saying that await is only valid async functions. Right, okay, so number 12. Right, okay. Okay, so this particular function, I mean, maybe that would work if we just made that an async function. Here we go. So it was just telling us that we can't use await unless the function that's using this is an asynchronous function, and it wasn't. So I've just made that an asynchronous function to solve that error. I mean, you might not even need to await this, to be fair. You could have just removed that instead. But we'll do that for now. And let's test that and see if this works. So we'll go back to our application. Let's just put in a username. Put in a different one. Let's just put in a Bailey. chrisb@gmail.com. And let's see what it says. See if we get any errors. Going over to MetaMask. It wants us to sign. It says we're logged in. There were no errors in the console. So let's go over to our dashboard. Let's refresh this. And let's see whether it's stored anything in those fields. Great. So in our fields now, in our database, we've got chrisb@gmail.com and Chris Bailey as the username. And there you go. So that is the first part done. What we need it to do now is to actually move us to our second page, which is, well, what other page do we have in our folder? We've got dashboard.html. So once we've signed in the user, we want to actually move the window to our second page. Now, of course, in an actual live application, you're certainly not going to use the solution I'm doing here, which is just a window.location.href and then move to dashboard. It's a very crude solution, but it does the trick for this tutorial. You'd actually have a proper routing solution where it moves them to the page in your app. So we'll do that for now, and let's just go back to the application. Let's just sign in. I'll leave those fields blank. It might throw an error, but we'll see. Okay. Okay, well, the page looks pretty ugly, but you can see that we have we've gone to a different page. And so now that the user is logged in, we've gone to this dashboard.html. It looks pretty ugly because we haven't played with this code yet, but you can see that we're somewhere else. So that's good. So that all the index side of things is all working fine. So let's go and play now with the dashboard.html file. There's going to be probably quite a bit to do in this one. So what have we got? Let's just, it's a completely new HTML file. So we're going to have to just tidy that up like we did with the login page. So we'll just go through this and see what we can do. Well, let's just change the title first of all. We'll call that something like dashboard. That should work fine. Okay, so there's only one CSS file here. We've got another one down there, which is going to need the same amount of work that we did on the previous one, which is to tidy it up. That particular file is going to sit in our CSS file that we got from Bootstrap. I mean, maybe we're going to need the, well, here it is. So let's move that up. That's the actual dashboard CSS file, which is good. So we'll put that in there. We've got this code here. It looks pretty similar to the other one that we had in our style.css. I'm just going to copy one of these, call that style.css, and let's just check that the code I've stolen from this one is the same. Looks pretty similar, so we've already got it. Let's duplicate. That's good. We'll save. Go back to our dashboard. We've got our CSS connections here, but what we don't have is our SDK here. Now, again, this give me some creative freedom here just for this tutorial. This is not the way that I'd recommend that you'd set out a two-page website. You'd want to have a different way of doing all of your headers and footers, so it's easy to manage, not duplicated like this, but it's just for tutorial purposes. And again, you can skip past a lot of this if you're already familiar with how to do it. Okay, so we're also going to need to, if we think about this, we're going to need our JS at the bottom of our page as well. There's a lot of stuff in here we don't need. I'm going to delete all of this stuff in a minute. Okay, so we've got some script tags down the bottom. We've got this particular one is referencing an old thing previous to our old CSS did, so we can remove that. This one is a CDN link, so that's okay. What else is it that we're going to need? We're going to need a reference to our main.js. Let's take a look and see how that looks now. So we want to run our dashboard HTML server. Oh, wow. Okay, that's good. Well, that looks pretty much like the dashboard. Great. So let's just hollow this out and take out all the things we don't need. For example, there's a whole list of stuff down the left. We don't need this chart here. We don't need any of this table data. Let's just hollow all of that out and get rid of it. So I can see a table here. So, well, let's just remove the whole table. There we go. Brutal. We've got this canvas here. That looks to me, my chart, it says, that looks to be the graph. So I'm going to remove that. And let's just save this, see what we have. Okay, good. So that's all of the data gone. We don't need that. We've got a section title here. We'll use that in a moment. What about this left-hand menu? Let's tidy that up. We can see a number of different list items here. Year-end sales, social engagement, current month. Yep, don't need any of that. In fact, I'm going to leave 1, 2, 3, maybe just 3 of these. So we're going to delete everything up to reports. So that actually was a UL, so I can remove that. UL. Okay, delete you. We're going to need that UL. That's the other unordered list. We don't need integrations, reports. Did we say to remove up to? Remove reports. Okay, good. So I can remove that. Make sure to keep the UL. Save that. Fresh. Okay, great. That looks good. We don't need these buttons over here, so let's go and find them and move them. We have... where would they be? Sign up button here. Sidebar, menu, dashboard, orders. Okay. Oh, this looks like it here. All right. So we can try and isolate this information. So we've got a button here that says this week, which we don't need. We've got these div here, which we don't need. We've got that toolbar. We also probably don't need. So we can isolate all of that and remove it. Let's see what that does. There we go. Great. Search is still here. Company name we just leave for the moment. We could change that when we tidy it up. We've got a sign out button that doesn't do anything. And we've got some links that don't do anything. So let's just now go back to our home page and see if this all connects up as we wanted it to. Or maybe we didn't call it home. Maybe it was called index. It was. Okay. We'll go back to our home page and let's just sign in. We'll leave that blank. And it should take us, there it does. Okay, great. Takes us through to the dashboard. Great. So the first thing I'll do is just connect up this sign out function, because what we want to happen is to remove our user and then take us back to the home page. Okay. So we'll go over to our JavaScript. We'll tidy up our document in a moment. Underneath our login function, we will start building out a new function, which we'll just call logout. This should be a really easy function. In actual fact, I think it already exists. It does. It already exists in our Moralis snippets. So what I did there is I just typed logout. It pre-populated moralis.logout function. When you click that, it populates the code you need. So it's an asynchronous function that simply awaits this method, which is the moralis.user.logout. And that's it. Now that will log the user out, but it won't take us back to the home page. So what we'll do is we'll just copy this line of code and we'll just ask us to move the window back to our index.html. So that is the logout function, which is great, except that we need to connect it to the logout button. So whenever that logout button is clicked, we need it to activate that function. So where is that sign out button? Does it have an ID? Can we use it? Let's go and find out. So let's go into our dashboard. I'm going to format this document just so it gets rid of a few things, tidies it up. Pretty gappy because we've deleted a lot of content, but hopefully you can see through this easily enough. That looks like the button right there, sign out. So let's just give that an ID of, well, it's a BTN. Well, let's just call it what it is. It's the BTN-logout. We'll copy that ID, save that, go back to our JavaScript, and we'll do exactly the same that we did here, but with logout instead. And that will then run the logout function. So it selects the button, and on the button click, it runs that, which is a function. So let's see if that works. It should hopefully send us back to the home page once we've logged out. So we'll click that. And it doesn't. Let's just see why it doesn't. Did we save everything correctly? Have we connected our dashboard? Yes, we did. Okay, good. And well, we better check the consoles. Okay, so we've got a couple of errors here. The first one is to do with a different file. We'll come back to that. Hello world. Okay, uncaught type error. Cannot set property on click of null. 24 in main, which is right. Okay, now this is kind of what we talked about a moment ago, where I said if this particular element doesn't exist on a page, it's going to throw an error. So we need something that's just a basic conditional that checks, does that element exist on the page? So I've copied that, and let's just separate that. Now, again, there's much better ways you could do this, but for the sake of the tutorial, I'm just going to run an if statement that says, if that element is not empty, or if that element does not return null, which means that the element is available on the page, then run that function. Otherwise, it just ignores it and it won't throw that error. And we're going to need to do something similar for this one as well, I guess. So and that's just because some pages will have the element on it, some won't. And when you're writing the click listener in this particular way, it will throw an issue if it doesn't exist on that other page. Okay, so let's just refresh that. We still have this particular chart error, and I believe that could be solved. It says it's in the dashboard.js number 11. So that's this variable. Well, we don't have a chart anymore, so we could just comment that entire function out. Yeah, I mean, we just don't need it. We don't have that particular function being used. Okay, so that was under the dashboard.js. I just pretty much commented out that entire function, the my chart function from line 11. Just commented the whole thing out. Maybe you could even just delete it. Okay, good. So let's test if this works. So we'll go to the sign out. And now we'll go back. Oh, it did. Well, there you go. Let's just sign back in and we'll just test that one more time. Sign in. Takes us to the dashboard. Sign out. Takes us back to the login. Great. Okay. Now, will it allow us? Let's just see if we have a user here. Moralis.user.current. Run the function. Null. Okay, good. So there's no user logged in. So will it let me go to the dashboard? Yes. So there's no check to say, well, is the user actually logged in? Because if they're not logged in, surely you don't want them to have access to the content. So you're going to want to make sure that there's a simple check, if you like, that enables you to always send them back to the home page to log in if they're not logged in, because you don't want to give them access to the content unless they're authenticated. Now, again, there will be lots of different ways that you can do this. It's more advanced to kind of do this, but I've got something on my clipboard which I'm just going to paste in here. It's a simple if statement. So if moralis.user.current is equal to null and the window location is not the home page, then hide everything on the page. So hide the body of the HTML and send them back to the home page. That's it. So that's all it's going to do. Is there a user that's logged in? If not, are they actually on the home page? If they are, we don't want to run this function or this redirect. But if they're somewhere else, if they try to go somewhere else, then we want to send them back to the home page. All right, so let's just save that and let's just try that one more time. Home page is not defined in our main 7. So let's just go back here. Maybe we should just probably easy for ourselves by just hard coding our home page in here. So our homepage is a localhost homepage. So we're going to need a reference to that as our local homepage. Yours might be slightly different depending on how you're running your application, but or maybe it's exactly the same if you're using the live server extension. So our homepage variable, which is what it's checking here, will be our hard-coded homepage. Yep. So let's check that. Try and log into our dashboard. Oh, better check that there's a user installed first. Is there a user? No, there isn't. And let's go to the dashboard manually. So we'll try and hack in. So it hides the content and it sends us back to the homepage. All right, so there's no unauthorized access to the dashboard unless we are signed in. Sign in. And that's fine. So it doesn't send us back to the homepage because we do have a user. You can see that here. Great. All right, so we're starting to make some progress with this then. So now we can begin building the fun stuff, which is the functionality to pull in all of the data, such as well, at the minute it says orders, products, and customers, but from our source, we want it to be something different. So let's just log back in the original one, transactions, balances, and NFTs. That's what we want it to do. So let's go and rename that, transactions, balances, and NFTs. So dashboard HTML. And let's go and find where they were. I may have gone past them. Probably did. There we go. Type it into the right place helps. Transactions. What was the other one? Nope. Balances and NFTs. Balances and NFTs. Balances, NFTs. Okay, so they will be the links. But what we want to do is we want to start creating some unique IDs, or trying to think about now how we want to handle this whenever it's clicked. So how should we name these? Well, where's the anchor text? The anchor is the link, so it's up here. So we want to give an ID to, well, the dashboard's fine, we can ignore that, but we want to give an ID to the transactions. Well, I was going to say, what are we going to call it? Well, let's just call it what it is. Get transactions. Link. It is a link. Let's just call it for that. Call it however you want it to be called. What do we want to do with the balances? We'll just call that get balance link. Get balances link, something like that. And the other one would be another one in this tag, or get NFTs link or something like that. Now, it's got a href already attached to this, but we can ignore that because we're not actually linking to a page. We're going to be hooking onto this anchor text and running a function instead. Okay, so what I might do is just copy those into my JavaScript just so I've got reference to those. So it is get transactions link. The other one was get balances link. One was NFTs link. Get rid of everything else and then just comment those out just so they're there for reference. We're going to need to write a function. We're going to need to go and get the balances, and we're going to need to try and think about what sort of information, sorry, not the balances, transactions. I read the wrong one. What sort of information is it that we're going to need? Because this is quite a meaty function. So in our source code, if you remember, whenever we click transactions, it's going to go and pull in all of this data. There's quite a few things there. So there's a lot going on under the hood. We're going to build a table with 1, 2, 3, 4, 5, 6 columns. We're going to need to pull in all of the different pieces of information for each transaction that we find. And of course, we're going to need to start with getting that data before we can do anything about it. How do we get that data? All right, well, we'll hop over to the documentation in just a moment because there's a simple function that we'll use. But let's just build the basics of the function that we want first of all. So we're going to connect to this get transactions link. When we click that link, it's going to run a function which we'll call get transactions. Nice and simple. Call your functions what they are. It makes life a lot easier when you're going back through your code a couple of weeks later. Okay, and in here we're going to do some stuff. So we'll probably build a connection to this get transactions as well. So we'll kind of copy this sort of style. So if this particular ID exists, then when it's clicked, run that function. And in there, maybe we can just put a simple console log just to see if it's connected or whether we get any errors. So get transactions. There we go. Transactions. So if we click on this, does it do anything? It does not. Have we forgotten to connect anything? We have transactions link, and to get transactions function, which will do a console log. There we go. Okay, maybe I just needed to save the file. Okay. So when you click on that now, it gives us the get transactions clicked. So we know that we've connected that button to the function. So now we need to go to the Moralis documentation and start thinking about how we can pull the data in from the blockchain. So this is what obviously you guys want to learn more about. So if we head over to the docs.moralis.io, now we're going to be using the Web3 API, the Moralis Web3 API. It's incredibly powerful. It's still being added to, and there's a lot of information that you can pull from the blockchain from users. And that's what we're going to do right now. Now, on the left-hand side, go to Web3 API, click on Account, because that's where we're going to find the functionality. Oh, and it's right there. It's the very first one that we need, which is to get transactions. Now, have a read through this page, spend some time familiarizing yourself with it. There's two ways that we can do this. We can simply run this one line inside our function, okay? Because at the moment our function is just going to say get transactions was clicked. So you can just replace that with this line of code and everything will be great. And this is the default. So what that means is it will get the transactions from the current logged in user and from the Ethereum mainnet. Okay, that's the default settings. If that's what you want, then that line of code will do everything you need. However, we're not going to be doing that because we are going to be using a test net. We're going to be using Rinkeby, which is a different chain to the Ethereum mainnet. And, well, the address is going to be our own address. So technically, we don't need to give it an address. But as we're going to be utilizing this options variable, we may as well just add an address in there just for showing you how to do that. So there are two things we're going to need. We're not just going to need that single line. We're going to need these two lines. So we'll copy both of those, click it over to our code, and we'll put it in here. We'll just leave that console log there for now. And there we go. So our options object has a few things in here. Now we're not going to need the order, and we're not going to need the from block. We're just going to need the chain, which in our case is going to be Rinkeby. And we're going to need an address. And in there, well, if we just go back to our user, go to MetaMask, and I'm just going to copy this. Paste that in there. Here we go. And then the next one is a transactions variable, which we will declare, which is going to await the Moralis.web3 API.account.getTransactions, and it's going to pass that options variable in, that object in. What do we do with that once it's done? Well, we may as well just console log whatever comes back in that transactions variable. Let's see what we've got to play with. Okay, that activates this one. Now it's being used. And so let's update that by saving our file, and we'll go over to our app and we'll click transactions and see what comes back. Excellent. Okay, so on this, in the console window, we can see that we got our console log. We have 12 that have come back here. And inside there, we've got all of the data for each one. We can hook into that information and take this data and feed it into our application, which is exactly what we need to do next. So on our main application, what we're trying to copy here, instead of just a blank section here, we've actually got, we just refresh this page, three titles that are just empty: transactions, balances, and NFTs. The first one we may as well just do right now is transactions. So let's just go down to our HTML for the dashboard. And it's a bit further down, I think. Here it is. Let's just replace this with transactions, because that's how we want it to actually appear on our application. We need to say transactions. And then underneath that, we've got this empty div called table responsive. Well, that's okay, because we can inject into that. But we need to be able to find a way of injecting into this empty div. And to do that, we need to give it an ID. So let's just add that in. And what do we call it? Well, what is it? It's a table of transactions. So, okay, so we'll just call it that. It'll just be a table of transactions, and that's the ID. So we'll be able to hook into that and build some code. And while we're here, we may as well copy that and just put the same for balances and put the same for NFTs. This one will probably, the balances, is that going to be a table? I guess it is, so we can leave that as that, but it's not going to be a table of transactions. It's just going to be user balances. And the other one will be that's going to be a table of NFTs. Again, just call it what it is. And that will be a responsive table as well. And we might want to add some extra classes to this, but we'll come back to that later. So we'll save that. Let's go back to our application. Here we go. We've got those. And so when we click this now, what we need it to do is to display the data in this transactions. So let's try and build that functionality out. All right. Where is our function? Well, it's under our main.js and it's in here. So we're going to need to add something extra in here now. So we need to build out a table. That's the first thing that we're going to need to do. Assuming that the function returns some transactions, which we should probably check. So let's just declare a variable here where we say, we already have it. We already have transactions there. We'll check how many transactions have come back. So it would be maybe transactions total. Let's just go back and have a look here. Transactions.total. There we go. So if that total is at least 0, it means that it's returned something. So if transactions total is greater than 0, then we want to do something. And the first thing we're going to need to do is populate our table, because we need some HTML to inject code into. So we need a table. So let's just get the table on the page first of all. And so declare a variable called table. And we're going to create what's a template literal. And that allows us to do sort of multi-line strings, basically. And I'm going to copy and paste out some basic code from the clipboard, because you don't need to watch me typing simple HTML. The HTML itself is going to be as follows. We are going to need a table with a class of table, and then the table head, which is connected down here. Then we're going to need the table row, and inside that table row, we're going to have 6 table headers. They're going to be columns, and the headers are going to be transaction, block number, age, type, fee, and value. And then that's the head part of the table done. And then we want a body with an ID of the transactions, because that is where we're going to inject our content into, in that particular body of the table. And then we close off the table, and that is the end of our table variable. So what we'll do now is we'll just go and inject that table inside the HTML in our dashboard. So we've got to go and select that and then change the inner HTML. So we'll go with this, copy that ID from that div. And let's go and select that element. Again, you could do it with getElementById by ID if you prefer. I just have a habit of using the query selector instead. You'll get the same result if you use getElementById by ID. You just don't need the hashtag with the getElementById by ID. And what do we need that inner HTML to be? Well, we need it to be the table. Okay, so once we now, let's just run through this. Once we click get transactions, we are going to get the data, store it in this variable. We're going to check whether there's some actual transactions in there. And if there is, then we will just write some HTML into here and then inject that HTML into our table of transactions in an HTML. Well, that should work. Let's just see what it does whenever we click transactions. Great. Okay. So that has now put in the basics of a table in here. So that's great. So we're now going to see if we can start injecting some of those transactions into our table. So let's see how we get on with that. Okay, so that's the first part done. Now we still have our transactions variable with all of our data here. So let's hook into that because we're going to need to loop through that now. So we've got all of our data in here. We're going to need to loop through each one of these 12, this array. Each one of these we're going to need to loop through and send some information into our table. Okay, so we'll get started off as we would do with any other loop, and we'll just create, we'll do a for each loop, I think, in this case. The transactions dot what? Okay, let's go back to our result. We want to hook into the result, transactions dot result, and at that point we're going to be given an array, and we want to loop through that array. So we need a for each loop, and what is it going to be given? It's going to be given as a transaction, so I'll just call that T. And with that, we're going to run some code. Okay. So what do we want to do with each one? So each loop, each time it goes through each one of these, we're going to need to build some HTML that gives us some of this stuff back. We're going to need 6 different table or TDs, basically. So we're going to need to declare some more content. So let's go and create another bit of content, or create a variable called content. Another template literal, similar to how we did this thing up here. In actual fact, we probably could just copy this and paste it here and just change what we need. Let's just tidy that up. So we're going to need a row, but instead of a TH, we're going to call this a TD. Okay, so I've just replaced those table headers with these TDs. And okay, in there, what we're going to now need to do, we don't actually need the scope. There we go, that's tidied. And so we are going to need to do the, how do we get the information, and what information do we need for transaction? So let's use the hash. So we can use this ES6 syntax, and we will go and get the t.hash. In this block number, we want to go and get the what do we say, block number? So block underscore number. Age. Okay, that one might be a little bit tricky to do. That might require a function. So we'll just leave that one blank as, well, let's just put the timestamp, block timestamp in there for now. Block underscore timestamp. There we go. Type. That also will be a function, I think, because we need to know whether it's going in to our account or whether it's coming out of our account. So for now, we'll just use the from address or something like that, just so we can put some data in there. It's not going to be what we need eventually, but we'll just put something in there, from address. Fee. Okay, now we're going to need to do some work on that fee, because we're going to need to multiply the gas to the gas price, and then, I mean, look how many zeros there are going to be on the end of that formula. We're going to need to convert that down to, I think that's in Way, and we need to convert that to ETH. I think it's like 18 digits that we need to change it back to. So we'll do a bit of a formula. which we can do in here, which is great. I think it was it gas? Gas and gas underscore price. Okay. And multiply that with gas underscore price. And so that's the basic formula. It's going to return a massive number. And we want to divide that by, I think it's 1 to the 18. And then we could probably put that to just maybe like, I don't know, 5 decimal places. Because if we don't do that, it's going to be a really big number. And we just want to format that. And then we'll just put the word ETH on the end of that. So that'll be the formula inside our block, and then ETH on the end. So it'll be like, you know, 0.0001 ETH would be the fee. And the value is going to be pretty much the same thing. What was the value? Well, in this case, that one was 0. Others might be bigger. So I'll show you what it looks like when you don't format the number and it just returns it in way. Well, let's see if we get any errors. So at the moment, that variable is not being used. So we're going to need to find a way of injecting that into this. So we will probably, let's try it first of all. Let's just see if it accepts it. We might have to create a new variable or a new connection. But we want to now, for each one of these transactions, once we've built our content, we want to inject that content into the body of our table here. And so we called that an ID. So see whether or not it recognizes it. It might not, but let's try it. Okay, so the transactions in a HTML will make it equal to the content of these. For each one of these loops, we're just going to append the content to the body of our table. It may throw an error, but let's just see what it says. And we'll click on that. Hey, great. Okay, well, it didn't throw an error. It actually gave us all of the data. And all right, well, let's just close the console for the moment so we can see this. And you can see that there's a few things I'm not massive fan of. How does it look on the previous version? So if we click on transactions, okay. Well, it kind of formats it. I think it's responsive table, so it's all dependent on how it would come across. Now, the type, of course, is not going to be an address. It's going to be incoming or outgoing. The age is a big one too, because it's not going to be a timestamp. It's going to be how long ago it was. And this transaction ID, I think that is quite long. Yeah, it is quite long anyway. So I think it'll be fine once we've tidied up a few of these columns. It will look similar. But you can see here how the value is just not quite right. I mean, it's not that many ETH. It's its values. So we just need to format that. And that's why we did that previous function here. Dividing it by 1 over 18. 1e18, should I say. And we'll try that again. Yeah, here we go. So we can see one where it needs to be almost like truncated, if that's the right word, I'm not sure, but cut down to 5 decimal places just to tidy things up. So that's why we use the to fixed on the end of it. Now we'll do the same again. Use the to fixed method, and 5 decimal places will work just fine. Just refresh, rerun that, and there you go. That's nice and tight. Great. So we're making some good progress here. I've just refreshed the application so it's got rid of my transactions. I'll just click those again. And we need to now build in some functionality whereby we want to turn this into a link, this into a link, and we want to run a function that converts that to something different and also this to something different. So it looks more like this. Rinkeby.etherscan.io is the link rather than the regular Etherscan. And you can see here that there's a URL, which is just HTTPS Etherscan. And we want it to, if you like, change our transaction data, convert that into an anchor tag that starts with that first part of the address, which I was over here now. I know I'm jumping between tabs, so please excuse me. So I'm going to copy this part of the link, close that down. May as well just close this down too. And let's go back into our JavaScript, and we can see here it's this bit that I need to change. Okay, because now we don't just want to provide that, we want to wrap that in an anchor tag, which at the moment probably won't do anything if I just stored that, but it should turn it at least into a link. Nope, maybe it doesn't. Okay, and of course the reason being you need to give it a reference. So if we refresh that, then it gives us a link. It doesn't do anything, it's just an empty link, but that is the basics of how we want to start with things. So let's go and give it now a link. Well, the link itself, we've got on our clipboard, the rinkyby.etherscan.io/tx/, and then we need to give it the actual hash itself. So we can just add that to the end of that link. And thinking about it, can we do that? We should be able to, because it's part of a template literal, so that's absolutely fine. It's a multi-line string that will enable you to combine HTML with JavaScript, so long as the JavaScript is inside a block with using this syntax. Okay, so that is the link, and now we're going to be going to an external link. So really, just good practice is to make sure you load it up in an empty tab, and you use the no opener. Yeah, no opener, no referrer is often a good standard to get into the habit of doing to protect your users. Okay, so that would be the HTML to convert the link or the hash into an actual usable link. Let's see if it works. We'll just load that again. Let's click it. It should open a new tab. It does, and it should open. Yes, that is what we like. Okay, the next one we want to do is convert the block. So if we go to the Rinkyby Etherscan, and let's just go to a block example. Here we go. And we'll copy that one. So instead of TX, it's now block. Go back to our code. Let's just copy the whole thing. Paste in what we need, which is that. A little bit of a long line, this one. Again, we'll do it as blank, no opener, no referrer, and what we want it to display is the block number, and what we want the link to go to will also be the block number, except I don't quite know where that came from. I might have copied that incorrectly from the URL bar. So we'll save that. Let's see if that works. Go back to our app, load up the data. It looks like a link. Let's see if it works. It loads a new tab, and great. Okay, so that's so far so good. It's great when it works first time. All right, let's move over now to age. So that is going to be a little bit more tricky. Now, what I've noticed here is we've introduced an error because we've now got 7 columns and we only want 6. So somewhere I've made a mistake. Of course, it's because I've got to remove the original block. We don't need that. We need our 6 TDs, not 7. So I'll save that and we will go back. That looks better. Okay, so we've got our transaction, we've got our block number linked, so that's good. So now age. Yeah, that's going to be the tricky one. So we're going to need a function in here because what we're going to need to do, we should hopefully still have our data in the console, do we? Yes, we do. So what we're going to need to do is consider what the current time is right now and also what the time was from the block stamp. We're going to need to pass that data that turns it back down to the number of milliseconds passed since 1970. We can take those two numbers away from each other, and then we can convert that back to a number of time. But the tricky thing is this. So for example, if we take away the times, so take away the time that this was created and the time it is now, let's say it returns 2 days. What we just want to have to say is that it was 2 days ago. But if it was less than 0 days, then we need to go down and check hours. And if it was less than 0 hours, we'll check minutes or something like that. So it'll just be like a series of if statements that we'll use. And while I've got the idea, I may as well just kind of start writing the function so I can talk you through what's in my head. So we'll just create something which is a function that will convert milliseconds to time, because that's what we're going to be left with. We're going to be left with a number of milliseconds once we've subtracted the block time and we've passed that into milliseconds. And we take it away from, it'll be the other way around. So the current time in milliseconds minus the block time in milliseconds gives us time in milliseconds. And this is just for reference at the moment. And then we're going to need to convert whatever that amount of time is in milliseconds into something that we can use together. So that's the function we're going to write. So we're going to need to consider it in days, hours, and minutes. So let's just think about minutes. Something was in the way there. Minutes. Okay, so we're going to need to do a calculation on that. So we're going to have to divide the number of whatever we get, our time in milliseconds. We have to divide that by 1,000 milliseconds times 60 to a minute. And then we will probably get a lot of decimal places on some of these. We'll come back to that. Now we'll do the same for hours, which is pretty much going to be the same thing. We can just copy these a couple of times, in fact, and we can just extend them. So that'll be times 60 again. And that'll be times 60 times 24. Okay. And we need to change this to hours, and we need to change this one to days. All right. So with the number of milliseconds we get back, we're dividing them by whatever it is to turn it into either minutes, hours, or days. Okay, once we've got that, we need to check from days. We'll work backwards. So if days is less than 1, then we'll do something. But if it's over days, as in if there is at least 1 day that's passed, then we'll just return how many days have passed. So we'll return string that says the number of days ago that it was. So that many days ago. That's the message that we'll get back. So if the calculation of how many milliseconds has passed since that block time happened was, say, 3 days ago, 3 days and 5 hours ago, it will just simply say 3 days ago. Okay. But if it's 0 days, then we need to drill down into hours now, and we'll just do something similar. If hours is less than 1. And we need to close that off. And we could just copy that, but hours. It's pretty primitive, this kind of code, but it should hopefully do the job that we would need it to do. As an example, again, if you find a more elegant solution, feel free to use that. But this will work just for the purpose of this example. If there's minutes is less, then we'll just simply return less than a minute ago. And else we will return minutes ago. Okay, that should work. Don't need that because we've already used it. And that should be our milliseconds to time function. So we're calculating how many minutes or hours or days have passed. So we're then checking, was the days less than 1? Were the hours less than 1? Were the minutes less than 1? And then it will just simply drill down into whichever one and return either less than a minute ago, or however many minutes ago, or however many hours ago, or however many days ago. And once we've got that, we can then call that in our table function here. So it's not going to be the block timestamp anymore. It's going to be to call our function. We're going to have to probably think about how to write that out, because we're going to need to pass some data. We're going to need to get the current time, first of all, and pass that. And then we're going to need to get the block time and pass that, and then run our function on the results. There's a few things there. So the current time, first of all, how do we get the current time? Well, you would just simply write new date. So let's just write this out in... That would provide the current date, and then we would just pass that. And we'll just check that in the console first of all, just to make sure I'm not barking up the wrong tree. Yep, it gives us a Unix number, so that's good. And which means we could do the same thing for the block time, which we already know, which would be this block timestamp. We could just simply pass that. And give it that, because inside our block we will already have access to that. Okay, I'll explain this in just a second. I'm just typing out what I'm thinking, and I'll come back to that in a moment. And then that's going to give us a number of which, that's going to give us a number of milliseconds, which we can then run through our function. Well, the best way to try that is to try it, and we'll see what comes back. So inside this block now, we're just going to paste this little function, which is run the milliseconds to time on a calculation whereby we're going to declare the current time, pass that so it's into milliseconds, get the block timestamp, pass that so it's in milliseconds, take one away from the other, and then pass it in through our function. Right, well, let's see if we get an error. Transactions, look at that. All right, so 15.7, what? We don't want all the decimal places, do we? Actually, we could probably just take out everything and just have 15 hours ago. So let's see if that was correct. I'll just try on our original one. That one was actually a day ago. Okay, well, let's just do a little bit of change. Probably be in our function. Okay, it'll probably be this number here. So let's try using a to_fixed method to just make it 0 at the end of this calculation. See what that does. Regenerate. 1 day ago. All right, good. For some reason, it did say 15 hours before, and now it's saying that. So I guess it's because it's less than 1 day. And if we've got a bug here. The timestamp was 30th of 2153. So that is less than a day ago. It's giving us 1 day ago. So I think I spotted a bug, and by accident. I'm wondering whether, just for the minute, just quickly, because you're going to have this happening when you're building your applications anyway, and it's good to get a feel for how you debug your applications. But it's not. Maybe I'm using the wrong method. Right. Okay, that will be it. So this to_fixed method is actually rounding up. And so 15 hours rounds up to a day. So I wonder whether we could just change that method to a floor method, math.floor. And that would not then round up. Actually, maybe I'll test that on days. That's probably the first thing. That was where the issue was. I'll roll that out. Yeah, 16 hours ago. All right, good. So there was a bit of an issue there with the method that was chosen. That's going to happen probably quite a lot, but you can always improve your application. And I think that's part of the process. You can always refactor your code to make it better, more efficient, leaner. Good. All right. So 15 hours, 22 hours. Okay, that looks a little bit easier. It's a small change, but yeah, as you can see, it improves it a little bit. So that is how you would get the amount of time ago that the transaction occurred. So I'm pleased that works. Now, the incoming and outgoing part. So let's think about what we're going to need to do about that one, because we're going to need to check whether or not the transaction address is the same as your current ETH address. So for example, moralis.user .current, and then we can do a get ETH address on top. That will give you what your actual address is of the current logged in user. So we know we can get access to that. So we can check that against the address that was in the from of the transaction. So the from address was available as from underscore address. So let's go back up here. Oh, we've already got it. So that's the from address. So what we can do is we can do a kind of like a ternary operator or a conditional operator, where we just say, look, is the from address the same as the Moralis user address? And then we'll literally just ask that question. So that's the question. Is the from address the same as the current ETH address? If yes, then give us outgoing. Otherwise, give us incoming. That probably is all we need. Because it's just going to return a string. It's just going to return a string of outgoing or incoming instead of what it was returning before, which was the address. So let's try that. Good. I wonder whether that is the same as the other one. We should probably check that. Yeah, it looks pretty good. And you can see that this is actually wrong because it says 1 day ago. So we've fixed a bug from the demonstration. And you can see all outgoings apart from 2 that were incoming. Great. And I think we're pretty much there with the transactions. That's complete. So we've linked it out to Etherscan for the transactions, pulled all of that data in from a very simple function, and then just manipulated it, really. But as you can see, Moralis actually pulls in a huge amount of data, and we've used 2 lines of code. The rest of it is just standard HTML stroke JavaScript manipulation of the data to render things on the front end of an application. But the hard work, the back end work, which normally takes like hundreds or thousands of lines of code and database functions and queries, is all done. So yeah, super simple. So I can delete stuff that I don't need now. And now we can start taking a look at the next piece of code, which is just pulling in the balances. So does it do anything when we click balances? No, it doesn't. So we will now connect that one first of all. Got a link on the get transactions link. What did we call the other one? It was called balances. Oh, handily, we put it there earlier. Anticipated what we might be thinking. And we're not going to call it get transactions for this function. We'll call it what it is. Balances. And it's going to be equal to an asynchronous function, which will run the following line of code. And yep, called it get transactions. And we'll just do the standard bit, which we did before. Get balances clicked. Make sure it's connected. And let's see what we get when we press it. Balances, get transactions clicked. That's fine. Get balances. Wait a minute. I think I might have connected that to the wrong button. Okay, have I? Yes, I have. Okay, there we go. We don't want to connect it to that. We want to connect our click handler or click listener to get balances function. So make sure you do the right one, otherwise you can have some unusual behavior in your application. We'll click get balances, and we've got get balances clicked. Good. So what do we want to do with that? Well, it's a similar setup to the previous function. We want to build the basic table first of all. So when you click that on this other one, we'll build the basic table. It's just a 2-column table. And then we'll inject whatever we get back into that table from the Ether, Ripston, or Rinkeby balances. Okay, well, we'll start off with the Moralis code first of all, shall we? Because let's actually just jump into the away from the HTML a little bit. How do we get the balance from our Ether address? How do we get the balance from Ripston? How do we get the balance from Rinkeby? They're the questions to ask. Well, they are going to be 3 separate functions, or 3 separate calls, should I say, to the same function, or the same method, because they're 3 different chains. Got the Ether chain, Ripston chain, and Rinkeby chain. We need to get balances. So let's go over to the Moralis, docs.moralis.io, and we'll go to account. And again, you probably read through all these pages again, but if not, I recommend you do that. Just familiarize yourself with how that works. Because the one we're going to be using is this get native balance. It returns the native balance for a specific address. And again, you can do that one of 2 ways. You can either just do a single line of code, which will produce the Ethereum native balance from the Ethereum chain, the ETH balance of the Ethereum chain, should I say, of the current logged in user. Or you can pass it some options and it will go to 2 lines of code. And that will allow you to change the chain for which it's going to return the data from. And that's what we need to use. So back in our code, we're going to copy this into our function. Where is our function? Here it is. So we'll just put it underneath that console log and let's hollow out what it is that we need. We don't need the other parts there. We're going to need the address will just be our logged in address. That's just the default one. So we really only need the chain as an object. Then I'm kind of thinking to myself, do I need 2 lines of code, or could I just do that? That should work too. Now this balance won't be called balance. It will actually just be called, well, let's just do Ripston first of all. Let's just test that. Ripston balance. And the chain that we want to search for is Ripston. Maybe we'll just console log that just to check that it works. Oop. Make sure you spell it right. And see what it returns. Great. Returns balance. So we need to get into that. So dot balance. And that's going to give us something which we can divide by 1E18. Try that again. 4.7 with lots and lots of decimal points, and you can fix that to 5 decimal places and add a string that says ETH after it if you wanted to. And then we know how the format of that is going to be, which we can use in a little bit after we're done. So to fixed 5, and we'll put, well, this is a console log, so not template literal, which is what I prefer to use. So save that, maybe that works. Yeah. All right, so 4.77309 ETH. That's the balance of that particular one. Okay, so that's the kind of formula, if you like, we're going to use to format everything that we've got. What do we now need to do next? Well, we're going to need to get the other ones as well. So if we just copy these 3, and so the first one is just going to be the native balance from the default Ethereum chain. It'll be the ETH balance from the Ethereum chain. So that will be the first one. The next one will be the Ripston balance, which is going to come from the Ripston chain. And the final one will be the Rinkeby balance from the Rinkeby chain. Now, there are others as well that you can search, you know, Binance Smart Chain or other testnet blockchains. But I'm just going to be using these 3 for this example. And, well, I suppose we could even just copy these in as well, just to test it in the console log. And I think that should be good to go. Test that in the balances. Great. Okay. So there we have the data. We know that we can get the data from the Moralis functions. 3 lines of code which searches multi-chain data and gets the balances from the logged in user. I don't think we've coded a huge amount of Moralis code yet, but we've done a huge amount of work with just, 5 lines of Moralis code to get the transactions and also to get all of the balances. We need to inject that now into our code. Now, we had something similar in the previous one, so we've already kind of done this before, so it should be easy to do. So we're going to go and get a query selector for the user balances. Where was the user balances? So we declared that down here. We did, it was probably just in the HTML. And, it was in dashboard HTML. User balances, this one right there. So that's the div that we're going to inject the first batch content into. So it's a query selector. Let's get the hashtag for an ID. And we're going to need to put some data into the inner HTML. I'm going to make that equal to template literal, because we're going to need to build a basic table. We can probably go and copy actually the old one that we did, previous function here. Yeah, we can probably copy this. Where am I there? Put that in there, multi-line string, template literal. Okay, so we're going to declare a table or create a table. And the head is not going to have all of these headings. It's just going to have a token and a balance. We can delete the ones we don't need. The token, which will be either ETH, or the network or chain it should be really. So I'll change that to chain. So Ethereum, Ripston, or Incubate, and the balance. So they're the only 2 bits that we need. And then underneath that, we need a body. And we're not going to actually need to do any loops in this. We can pretty much put everything in the body. We don't need a specific ID. We've got all of the data already. We pulled that in. In fact, we've just worked on it. So we can just produce a couple of these. And the only thing with template literals is that it doesn't auto-populate HTML syntax. It's not the end of the world. I have bigger problems than that in the world of development. And the first one's probably just going to be a table header. First one's going to be Ether. We've already got the code for Ether, so we can just do. That should work. We're going to be putting this one in my favorite, which is blocks. Makes life so much easier. And it'll be ETH balance divided by that. Fix 5. Is that correct? Maybe I need that. There we go. I missed out a parenthesis. And then we'll just put ETH on the end. Okay, good. So that should be fine. We'll copy and paste this a couple of times. And then we'll do Ripston balance here. Actually, I think I just need to copy that. And that. We'll just call this one Ripston, and we'll call this one Rinkeby. Okay, so we've already pulled the numbers in. We just saw those a moment ago. So now we've just simply hard-coded this table with the title that will say Ether, or Ripston or Rinkeby, and its corresponding balance based on what we just tested in our console log just a few moments ago. So that's why the console log's so useful. And we'll save that. Let's see what errors we get, if any. Balances. Do we get any errors? We don't get errors, and we get a table with our balances. Superb. All right, so we're flying through this pretty well. The final thing we now need to do is just connect our NFTs, and we will be able to bring this to a close for you. So I hope you followed me through so far. I hope it wasn't too dull doing some of the HTML manipulation, but we're nearly there with our final function for get NFTs. Right, so we've got the transactions complete. We've got the balances complete now. We need to write the functions for getting the NFTs. So what this will do is it will actually search the logged in user and go and retrieve all of the different NFTs that they have in their account. And then we want to display all of that in a card format, which would use some Bootstrap and some Bootstrap styling. And then it will just return what we have back. We're currently logged in, so we have a logged in user at the moment. But when we click on Get NFTs, it's not going to do anything. So let's just connect. So we send a message to the console first, and then we can start writing out the functions with the new Moralis Web3 API functionality. It's pretty hot, pretty fresh. It's just been released, and it's very, very powerful. There's lots of different endpoints which have been converted into functions that you can use really easily inside of your code. So that's where we're going to go ahead and find our NFTs. So Web3 API account, and we're going to hook into the get NFTs function. So we'll get all the NFTs from the current user or address. It supports both ERC 721 and ERC 1155. It returns an object with the number of NFT objects that the user has, and then we can go into that and display the data inside it. The options that you can give it would be the chain for which the NFTs are stored. In our case, they are going to be on the Rinkeby chain. That's where we have our NFTs. Where in your case, you may have some on the main Ethereum network. If that's the case, you can just default to the regular ETH chain, and the address for the user, which we'll need to input as well. We'll pass that into an options object, and then we will put that into our Moralis function. So 2 lines of code will be able to retrieve the data that we need to then display it in our app. Let's go over to it. Okay, so in the JavaScript, we'll just scroll down to the bottom of our functions. And the most recent one that we wrote was get balances. And so let's just copy that, and we'll call the next one get NFTs. And inside here, we'll just write a message. Get NFTs was clicked. We'll connect that to the dashboard button. Where would that be? It would be this one here with the ID of get NFTs link. Done this a couple of times now, so I will just copy this relationship here. If that link is on the page, then when it's clicked, run this function. Okay, let's save that. We'll go back to our application. And if we run that and click get NFTs, there we go, get NFTs clicked. Great. So let's go and run our logic inside of that function. So the first thing that we're going to need to do then will be to go and use that Moralis code. So we need to get the NFTs. So we're just going to declare a variable here. Let's just call it NFTs. And we're going to let that equal to the code that we had here. Copy that. Just paste it in here for the moment. And we want this bit here, because actually in our case today, we don't really need the 2 lines of code. We don't need to pass a separate options object, because the address is just going to be whichever logged in address is using the application. So we don't need to pass a specific address. And the chain that we're going to be using, we already know, is Rinkeby. So I'm going to hard code that for the purpose of this example. And because it's only just a single parameter, we can just pass that in directly as an object into our single line of code. So our NFTs variable will await moralis.web3api.account.getNFTs, and it will search the current logged in address on the Rinkeby chain, and it will go and get the NFTs. We'll just check what comes back. We should get an object, providing that the logged in user that I have has some NFTs, and it does. It has 5. So this returns an object of which inside that object, so we're going to need to go with NFTs.result to get these 5. Then there's an array which we can loop through, and for each one of these, we'll go and get the information that we need. Now, when you're looping through NFTs, the one thing that you would generally need to do is to get the metadata. Now, in the case of get NFTs, it looks like it's already resolved, which is fantastic. It means we don't need to do lots of fetching and then conversions. We should just be able to go in here, so which would be nfts.result.metadata, and see what's in there. So if we do a for loop, for example, or for each loop, let's have a look and see what comes back in this inside the metadata for these NFTs. Okay, so we need to first of all check whether there are any NFTs. So we need to check inside there. What does that return? So returns an object, and then we need to get the array from result. So we need to check NFTs. So, nfts.result. So if nfts.result, the array that comes back, if that's greater, the length, I should say, is greater than 0, then we can run this block of code. If there are 0, if there isn't going to be an array that comes back, which means we won't be able to run this for each loop. So providing that there are some NFTs, then the nfts.result can have a for each run on it, and that will return an NFT. We'll just call that n, so we can distinguish it from everything else. And the n is going to be each one of these NFTs in the array. So it'll be n.metadata that we need to bring back. So let's just console log, see what happens. If we get an error, we'll try and fix it. n.metadata. And let's see what comes back when we run it. Okay, so we have some data come back, but it's not in a format that we can really use. So we've got an object, but we really need to convert that object into JSON. So we need to pass that so we can go and dive into it and get the information that we need. So for each one of these, rather than just console logging the n.metadata, we actually need to console log the past version of that. And there's a method we can use called json.parse. And if we just run that inside that function or that method, and let's see what that brings back. That's better. There we go. So each one of these now can be used. So we can go inside each one of these and collect the information that we need. We've got a description, we've got a name, and we have an image URL, which is an IPFS URL. Okay, so we'll come back to that in a moment, but that will need a utility function to help us turn that into something usable. Okay, so let's go back to our code. What we need to do first of all then is just let the metadata, we'll declare a variable, let the metadata, and we'll turn that into the past version of the metadata. And then with that, we can dive into it and retrieve the information that we need. Okay, inside here is going to be the metadata. We'll dive into that once we have declared our HTML block, which we're going to put onto our application in a moment. And inside our HTML block, so our content, we're going to need to write some card HTML. So if we go over to Bootstrap, and let's just go and get what we need. We could just type card. Yep, so this is kind of how each NFT will look. There'll be an image, there'll be a little title and description, and if we need to, there'll be a button, which we'll probably ignore the button. So that's going to be our image, that will be our NFT name, and this will be our NFT description. And then because of the code we're going to use from Bootstrap, it will just convert it into this card format. So we've got an option here for a card, so let's just copy all of that and put it in our content block here. Let's just format it so it's all aligned. Okay. Right, we don't need the width. Let's just tidy this up. So we have an image, which we're going to need a source for in a moment. That's the card image top. Alt tag is important for SEO. I recommend that you put one. Also useful for user experience for those that are partially sighted. But for the purpose of this example, I'm going to ignore the alt tag. And then underneath that, we've got the card body, and we have a card title. And in here, well, we already know that we're going to be using the metadata dot name, I believe it was called. Let's just go and check. Metadata.name and metadata.description. And in here, in the description, in this content, the body of this p tag, do another JavaScript block, and in there, metadata.description. I'm going to remove that button because we don't need a button in our card. Maybe we'll just put a fixed height of, say, 300. That helps with content layout shifting, which is core vitals, important for core vitals. I'll just do that for aligning everything so it's the same. And then once we've done or created this content block for each NFT, we then need to inject it into our HTML. So we've got to go and find our HTML, and let's think about where that would be. So that's in our dashboard, and see where the body is. So it's here. So table NFTs. We've got an empty div here called table of NFTs. So let's just go back to our JavaScript, and somewhere up the top of this function, be underneath this console log here. Let's just, we'll call it let table NFTs equal the document dot query selector or get element by ID, whichever you prefer. Make sure you put the ID tag, and we'll leave that there. You might not even need to create this relationship. I've done it a few times where I haven't written this, but it still manages to find the HTML when you write something like this, because this is the name of the ID in the HTML. So if it can't find it in a JavaScript file, then it seems to go and find it in HTML instead. So we now need to add our content block into the inner HTML of that table of NFTs, which is going back to the HTML. Let's see if we've missed something out or whether that works. Okay, well, it returns something. We have some information here. They're all kind of different widths. It looks a little bit ugly. It's missing the image. So there's a few things we need to do to fix that up. First thing we can do is just add a style to our card class here. We know that we can probably fit 4 NFTs next to each other, and it shouldn't look too bad. So we can use a style class called column medium 3. Let's think what else we can do. We probably need to think about flexing. I think we did that already. Okay, yeah, we've got a style in here in the HTML on the dashboard, deflex and flex wrap. That's just utilizing a CSS class called flexbox. If you're not familiar with that, it's outside of the scope of this video. Go and spend some time understanding flexbox. It's a really, really useful tool for getting your styling how you want it to be. Let's see if that fixes anything. Looks better. Okay, good. So the console's taken up quite a bit of real estate there, but you can see here that it's put 4 in a row and then it's wrapped the 5th one underneath. That's what the wrap did. And the flex just meant that everything's right next to each other. So it's almost like floating in old school CSS, but not quite. It's a little bit better. Okay, good. So we need to fix the image issue now. So let's go back to the block. Now in here, normally you would just decide whatever the image URL is, which in our case would be metadata dot, I think it was image underscore URL. Let's just check that again. Dive into this one. Well, yeah, image underscore URL. We didn't console log our past NFT data. Yeah, we didn't. Okay, that's fine. So let's just see. This will likely produce an error, and I'll show you why in a moment, but let's just see what comes back. Okay, yeah, we got 5 errors here, and that's because there are 5 images, and the error is because we're trying to pull an image from an IPFS URL. So we can copy this link and we can paste it into our URL bar, and it will show us what that is. We just can't pull it in to our application in the normal way. We have to convert it. And in order to convert it, we have to use a function. Now, I watched a previous video that Ivan did a little while ago, and with that, I copied the function that he had. So I'm going to paste that from my clipboard into the app, and I'll talk you through what we're going to do. Because we're going to run that fixed URL function around the URL. And then what that's going to do is as follows. It passes the URL that we get back into the function. It checks, does the URL start with IPFS? Well, we know that it does because you can see it here. It starts with IPFS. So if that's the case, what it's then going to do is return a link that begins https://ipfs.moralis.io, and then it runs this particular IPFS endpoint. It then adds the rest of our URL, but it cuts off this IPFS part of the URL. And then it just takes it out of an array and plonks everything else into the onto the end of the URL. And the result of that is that you will get a regular HTTPS link that replaces this, and then it will just render as normal in your application. So that's if the link starts with IPFS. If it doesn't start with IPFS, then it just simply returns the URL and it just adds format equals JSON to the end. Okay. So if we save that, let's see if that fixes anything. It doesn't. Fix URL is not defined, so we may well have spelt that wrong. Yeah, we did. It's case sensitive, so we need to put fix URL just like that. Save that. We'll rerun it. And there you go. Great. And that's our 5 NFTs that we have in this Ringabee account. Don't worry too much about what the content of them are. A couple of them are just examples, but you can see that if you have some NFTs in your account, you can pull them in to your application with just a single line of Moralis code. And then with a little bit of HTML manipulation, you can convert it and render it into the front end of your application. Superb. So all in all, guys, what we've done is we've created a mini application that allows you to sign in and authenticate your users. You can view the transactions, the balances, and the NFTs using just a few lines of Moralis code and display a relatively powerful application with very, very little knowledge of how the backend is going to work. And that's the power of Moralis. It just helps you build faster. Guys, that brings us to the end of this Ethereum Programming for Beginners series. And the purpose of this video was to really give you an insight into how, with just a few lines of very, very simple Moralis code, you can interact with the Ethereum blockchain and create an application that pulls information off the blockchain and displays it, renders it on the front end of your application. We went through some HTML and CSS via Bootstrap. We looked at some JavaScript functions and how to run some utilities to convert things like the milliseconds and convert links that are not quite renderable from IPFS to HTTPS. And we produced the basis of a wallet. Effectively, there are a few other functions that a wallet might have, such as, for example, transferring tokens, transferring NFTs. At the moment, we've just displayed the information that already exists in your account. So this is a really, really good start. And if you want some extra work here to begin developing this, then I challenge you to find a way of turning and converting these static HTML files into something that's a bit more dynamic, perhaps into a React application or something else. I also challenge you to see if you can convert this search bar into something that is usable. So rather than just returning the NFTs and the balances and the transactions from your own address, see if you can utilize this search bar so you can paste an address in here and the functions will actually run on that instead of your own account. So that's another thing that you can do. Another thing we'd like you to perhaps try and develop, because I have hard coded quite a lot of this application for using the Ringabee testnet. Now you might have things on Ripston or Binance Smart Chain or Matic or whatever other chain you use. So convert the application so it actually runs across multi-chains as well. Down the left-hand side, you've got the transactions and balances and NFTs. Why don't you see if you can create another one that would be specifically for the profile of the user, where you can begin adding things like an avatar or a biography about the particular user and save that information so they can access it. These are the kinds of things you can begin to build into. And that is where I'd like to leave this series. So thank you again for your time, guys. I hope the content was useful for you. If you enjoyed going through that, please leave a like on the video, subscribe to the channel, and leave a comment as to what other functionality perhaps you would like to see or how you'd like to develop the application yourself. Once you've got something that you want to display, share it with us. Share it with us either in the Discord channel if you're a Moralis mage, and or send it through and we'll take a look. Look forward to catching up with you guys in the next one. We'll start developing this particular dashboard a little bit further in the next series, where we'll start looking at transferring tokens and transferring coins, balances, and also transferring NFTs. So we can really start to build this out into an actual usable wallet. We'll see you in the next one, guys. Continue building. Take care.